Welcome again, once again, ladies and gentlemen. Tonight, we're going to go over 3.2 using transversals with parallel lines. I just want to point out that when you have two lines that are parallel and you use a transversal, um, things start to become a little bit more easier. You'll see in the next few slides. The objective today is students will be able to use angles formed by parallel lines formed by a transversal. Um, the essential question: how are corresponding angles and alternate interior angles related for two parallel lines and transversal? We'll get into that. Let's review a few things. Corresponding means matching, alternate means opposite, consecutive means same side, interior means inside, exterior means outside. Parallel means intersecting, not touching. So remember that these two lines that are being cut by transversal, those original two lines will never touch. Okay, they will go on forever in each direction, and we are going to go on to the next slide. So postulate 15, the corresponding angles postulate. The corresponding angle postulate says that if you have two lines cut by transversal, two parallel lines cut by transversal, then the pair of corresponding angles are congruent. So I want to point out, let's go with angle 2 and 6. If you look at 2 and you look at 6, when we say corresponding, let's see if I can write this down. This means matching, okay? Matching positions. So let's go ahead and put matching positions. So that means that angle 2 is on the right and on the top of the line. 6 is on the right and top of the line. So that's why 2 and 6 are corresponding angles. 1 and 5, they're both on the left of the transversal, and they're both on top. 3 and 7, they're both on the bottom, and they're both on the right. 4 and 8, they're both on the left and on the bottom. So that's why you have 4 pairs of corresponding angles. Okay, they're just matching each position. Next slide. It's a theorem. In interior and exterior angles, you have the same theorem, the same spirit, except we're talking about inside and we're talking about outside. Okay? And when we say alternate, we mean opposite. Okay, so it needs to be on opposite sides. So if you have two parallel lines cut by a transversal, here's your transversal, then opposite sides of transversal, then pairs of alternate interior angles are congruent. So I have here 3 and 6. 3 and 6 are on opposite sides, and they're on the inside of your two lines. 4 and 5, they are on opposite sides, and they're on the inside. Likewise with alternate exterior. 1 and 8 are on opposite sides, and they're outside. 2 and 7, they're outside and on opposite sides. Next slide. So when we talk about theorem 3.3, consecutive interior angles, you notice I have this underlined. Let me go ahead and kind of make this more transparent. We are not talking about congruent when we talk about consecutive. Okay, so consecutive means same side. If you need to write that down, write that down. Consecutive means same side. So 4 and 6 are on the same side, 3 and 5 on the same side. And when these lines are parallel, then 4 and 6 are going to equal 180 degrees. Okay? Likewise, with 3 and 5, when they are on the same side of parallel lines that are transversal cut, then these will both equal 180 degrees. Okay? So when you add them up, you're going to get 180 degrees. If you don't have 180 degrees, you don't have parallel lines. But you'll learn about that in your next section. So with those 4 things written down, we can use that information to solve this stuff. So let's look. There's a couple things we want to talk about. Number 1, vertical angles. Vertical angles are congruent, okay? So let me put congruent here. And when we say vertical angles, we mean this right here, okay? Angles that are across from one another. I know that's an ugly picture, but look. Those angles are congruent, and when we have two bands, these are congruent. Okay? And then we know that a straight line is, let's go ahead and put that out there. A straight line is equal to 180 degrees. Okay? So let's use this information. If measure of angle 1 equals 105, let's put 105 right here. Okay? So if measure of angle 1 is equal to 105, find the measure of angle 4, 5, and 8 and tell which postulate you use for each one. Well, for angle 4, if you're looking at this picture, angle 4 should pop out as the easiest one because we know automatically that that'll be 105. And we know this because of vertical angles. Okay, vertical angles. If they're across one another, they're going to be congruent. Angle 5. Angle 5 is going to be 105 degrees because, let's go ahead and write this in red so you can tell that. 1 and 5, if you look, they are both on the left and they are both on the top. So when we talk about these two, we are talking about these are corresponding. Let me see if I can write that a little better for you. One and 5 are corresponding angles. And if you have parallel lines, which we do here, then we know that corresponding angles are congruent. And then let's look at angle 8. If we look at angle 8, we know that angle 8 has to be 105 because they are on the outside of your two lines. Look at 1 and look at 8. And they are on opposite sides of your transversal, which is this line right here. So 1 and 8 are congruent because of alternate exterior. Okay, they're on opposite sides and they're on the outside. Okay. Let's look here. So I'll give you a couple minutes. Go ahead and pause the video so you can write that information down. I'm going to go ahead and hop to number 2. Ooh, let's not do that. Okay. And I don't know why it's acting like this, but let's see if we can go ahead and get something going here. Okay, sorry for that. Number 2. So number 2 says if the measure angle 3 is 68, okay, so let's put 68 degrees right there. And the measure of angle 8 is, let's look, 2x plus 4 degrees. What's the value of x? And then we need to show our steps. Okay, first and foremost, they're on the same side. Okay, they're not on the inside, so we can't call them consecutive. We can't call them alternate because they are on the same side. And we can't call them corresponding because this one's on the left, this one's on the right. So what we need to do is figure out another angle that has a relationship with 2x plus 4. Okay, now the easiest way to do that is to find angle 4 first. You can figure out angle 1, because angle 1 and angle 8 are alternate exterior. You can figure out 4, and those will be corresponding. So I'm going to go ahead and figure out angle 4 first. So show your steps. So the measure of angle 4, okay, is equal to 180, because remember, a straight line is 180 degrees. 180 minus 68, okay, because we already have 68 on this straight line. So if we have 180 minus 68, then we'll have 112. Okay, so we know that the measure of angle 4 is equal to 112. And so now we know that angle 4 and angle 8, those are corresponding. Okay? And then if you look back at your notes, you know that corresponding angles have to be congruent. And when we say congruent, we mean equal. So we know that 112 got to equal 2x plus 4. Okay? And then, it's algebra 1 from here. You subtract 4 on both sides, so that's 108 equals 2x. And then 54 equals x. Okay, and then remember, I always want my variable on the left for some reason. So x is equal to 54. Okay, here are my steps. I figured out what angle 4 was. Those are corresponding. And then we figured out that it's 54. You could have also did angle 1. Let's go ahead and erase that. You could have also did angle 1. Angle 1 would have also been 112 because of straight lines. And then 1 and 8 are alternate interior, but you still would have gotten x equals 54. Okay? So, I mean, it's just kind of what you want to do, whether you want to do two corresponding angles or two alternate exterior angles. All right, let's look at number 3. Suppose the diagram in example 4 shows yellow light leaving a drop of rain. So for your picture, draw this line right here. Draw that line. Draw this line right here. And then draw this line right here. So we have two parallel lines. How do I know that they're parallel? I have this arrow and I have this arrow. Okay, so these are parallel lines. And then this is your transversal. This is a line that cuts through two lines. Yellow light leaves the drop at an angle of 41 degrees. So here's my drop, and I know that this has to be 41 degrees. What is the measure of angle 1 in this case, and how do you know? Well, if you look at angle 1 and you look at angle 2, angle 1 and angle 2 are on the inside and they're on opposite sides of your transversal. So we know that they have to be alternate interior. And since they're alternate interior, then we know that they have to be congruent. So we know that angle 1 has to be 41 degrees as well. Okay? The measure of angle 1 is equal to 41 degrees. So, knowing these guided practice, go ahead and give your homework a try. And until next time, I'll go ahead and see y'all later. Peace. 2 fingers.